Okay, good morning. So we'll start the session. So actually we are going to discuss a problem regarding IPv4, and today we are covering IPv4 and IPv6 session. And from the next lecture, we are discuss the distance vector routing protocol, uh, link state routing protocol, RIP OSPF, these different protocol in next week. So we'll see these problems already I have uploaded on Moodle, and the same problems are available in PPT also. So you can refer the separate file or the unit 2 problem where the problem and solution is available. So today we'll discuss this problem, and these problems are completely depends upon IPv4 datagram format, packet format. If you could understand IPv4 format, you can easily understand these problems. The problems are very easy. Orally, you can easily calculate the problem and you can tell the answer. Now we'll see the first problem. Given a fragmented datagram in IPv4 with an offset of 120, how can you determine the first and last byte numbers? So we have seen how the offset value is calculated. Offset value is calculated by the first byte number divided by 8. Divide by 8. Why actually we store this data in a byte format? Because to define this offset value for 65,535 bits of data, the less bits are provided. That's why we have to divide by 8. Now here in this problem, a given fragmented datagram in IPv4 with an offset of, so offset value is given 120. So how can you determine the first and last byte number? So if the 120 is given, offset value is 120, we can determine the first byte number. How we can determine? Simply you have to multiply 120 by 8. So when you multiply 120 by 8, you will get the first byte number, right? Because how the offset value calculated? First byte number divided by 8. So if the offset value is given, simply you have to multiply offset value by the 8, you will get the first byte number. So you get the first byte number. But how we can determine the last byte number? So to determine the last byte number, we should know the total length of a datagram. If you know the total length of datagram, then you can determine the last byte number. But here, the total length is not given, so we cannot calculate last byte number. But we can calculate the first byte number by multiplying by 8. 20 multiplied by 8 or 960 bytes. So 960 byte, this is the first byte. And last byte number can be calculated by adding a total length field and subtracting 1. Ways you have to remember total length minus 1 because you are starting from 960. So it is like if you are starting from 0, always, and if you are calculating 10 number, so always 10 minus 1, that is 9, because you have started. Similarly, always you have to remember this thing, the total length field and subtracting 1 to get the last byte number. Second problem, is an IPv4 datagram has arrived with the following information in header in hexadecimal. So in hexadecimal, the data format is there. So 4 means the 4-bit representing a 4-bit. So if you see the header format, the first field which represents a version, right? So here this 0 multiply, this symbol is for the hexadecimal. So here 4 means for 4 means which represents the version. The next field is header alien. So H alien value is 5. So we have seen yesterday again I have discussed the same concept. So 4-bit you can because the 4-bit define the header length, and in 4-bit you can write a value up to the 15 only. So 15 and the header length is 20 to 60. So how you can write 60? So whatever value is there in header length, that value you have to multiply by 4 to get the header. So when you multiply by 4, so 15 into 4, that is 60. So the same concept you have to apply here. So here 5, what it means? The 5 multiply by 4 and you will get the header length. So what is the header length? That is a 20. Then the next 8 byte represent the service. We have seen type of service and differentiated service. So here the for 8 byte means 00. 00 means the type of service. Means the services are 00 by default, the normal services they are using. And the next 16. The 16-bit define the total length. So 0054. 0054 total length. So in hexadecimal 54 is a total length. So you have to convert into the decimal, you will get the total length. In this way, this problem will be calculated. Difficult to explain orally this problem. I will solve this problem on paper and upload the same problem solution through the Moodle. It is very simple. Like this wise, we have to write this value in a header format and you will get the answer for these different questions. So I will write this value into the header format and I will answer all these questions here. Like, is the packet corrupted? Are there any option? Is the packet fragmented? What is the size of data? How many more routers can the packet travel to? So whatever the value came into the time to live field, that is the answer of how many more routers can the packet travel to. Similarly, you can easily answer all these questions if you write this value in the respective field of IPv4 datagram. So this is very simple. When you see the solution, you will easily come to know how to solve this problem and you can answer all these questions. So already I have answered the questions. Only the thing is remaining that we have to write this received value into the IPv4 datagram format. If you will write these values, like 4 is for the version, 5 is for the header length, the 00 is for the services, 0054 is the total length. So when similarly, if you write this value into the header format, IPv4 header format, you will easily come to know how to solve this problem. Okay. So I will share this problem later. We'll discuss the other type of problem. Okay, so the third problem, an IPv4 datagram arrives with a fragmentation offset of 0. So when IPv4 datagram arrives and the fragmentation offset is 0. And an M bit is for the more fragment bit of 0. And then the question is this a first fragment, middle fragment or last fragment? Now, offset value is 0. What do you mean? This is the first fragment or last fragment. M means more fragment. M is equal to 1 means yes, more fragment. M is equal to 1 means yes, more fragment. If M equal to 0 means no fragment. So it can be the last fragment. So because M is equal to 0. But fragmentation offset is 0. So fragmentation offset means the first byte divided by 8. So if it is 0, what it means? This is a first fragment. And the datagram is not fragmented. That's why M, it is not divided. That's why M is equal to 0. If M is equal to 1 means the datagram is fragmented. So here we can answer this is a, because the offset value 0. So it cannot be the last fragment of a fragmented datagram. The datagram is not fragmented. Okay, so the problem is a little bit confusing. Like M is equal to 0 means this is the last fragment, but offset value is 0. What? This is a first fragment. Right? So actually, this is the first fragment, not the last fragment, because offset value is 0, or the datagram is not fragmented. Okay, the next problem. The value of a total length field in an IPv4 datagram is 36. So here the total length value is given, that is 36. And the value of header length field is 5. So header length field value is 5. So how many bytes of data is the packet carrying? So here the total length is 36. So what is the header length? So header length value is 5. So IPv4 header length should be in between 20 to 60 only. So value is 5. Always remember that value will be multiplied by 4. So 5 into 4, that is 20. So what is the header length size? 20. Because whatever value in the header length field, that is multiplied by 4. So 5 into 4, that is 20. And total length is 36. So how many bytes of data is the packet carrying? So datagram size is equal to total length minus header length. So datagram size is equal to total length is 36 minus header length is 20. So 36 minus 20 is equal to 16. So 16 bytes of data packet carrying. So here is the solution. 36 byte minus header length into 4, that is 36 minus 20 is equal to 16 bytes. Next problem. A host is sending 100 datagrams to another host. A host is sending 100 datagrams, a different 100 datagrams to the another host. If the identification number of the first datagram is 1024, what is the identification number of the last in IPv4? So what is the concept of identification value? At the source side, there is one counter. Whenever datagram forwarded, the counter incremented by 1 and the counter value will be copied into the identification field. So for every data, sequentially, the value is incremented. So the first datagram is 1024, the next one is 1025, next one is 1026. Again, here you have to remember the first datagram value is given 1024 up to the 100. So you have to add 100 minus 1 because the first number, the first value is given. So for every datagram, the value will be incremented. So 99 times the value will be incremented. So 1024 plus 99. That is the last identification value. So 1024 plus 99 is equals to 1123. This is the answer. So the concept is very simple. If you could remember the whole concept, how the IPv4 datagram forwarded, you can easily solve this problem. But here you have to remember the first byte number is 0 to 4. So you have to add 99 instead of 100. Otherwise your answer would be wrong. The next problem. Can the value of header length in an IPv4 packet be less than 5? When is it exactly 5? Value of the header length in an IPv4 packet is less than 5? No, because IPv4 is vary in between 20 to 60, and whatever value is there, which is multiplied by 4. So 5 into 4, that is a 20. That is the minimum header size requirement, that is 20 to 60. So definitely if this value is less than 5, it means the value is less than 20. It means the packet is corrupted. So value should not be less than 5. Right? So the value should be in between 20 to 60. So accordingly, 5 multiplied by 4, that is a 20. And when is it exactly 5? When the header size is 20, if the option is not available, we have seen in IPv4 datagram, if the option is available, your data size vary in between 20 to 60. If the option field is not available, that time the value is exactly 20. Okay, so here is the solution. Next problem. Which field of the change from router? Router. So actually, which field change? Normally, if the datagram is not fragmented and the packet is moving from router to router, mainly the time to live field, the time field changes. Because as the datagram passes from router to router, this time to live field decremented by 1. I hope all you remember this concept. Time to live is the survival time, for what duration the packet will be survived in the network. Right? So the total length is nothing but the total number of router the packet has to pass to reach a destination. So double value of total number of routers required to pass the packet to reach a destination added into the time to live field. And this value is decremented as the datagram passes from router to router. So if datagram is not fragmented, means the time to live field change. But the datagram fragmented, then the many field changes. Like your total length changes, offset value change, again your flags change. So these are the different changes when your datagram move from one router to router. Now we'll see. Calculate the header length in IPv4 value if the total length is 1200 bytes. So total length is given 1200 bytes and 1176 of which is data per length. So header length here we have to calculate and the data length is given. So what is the formula? Header length is equal to total length minus data length. So simple. You have to subtract 1200 minus 1176. So answer is 24. Hello? Okay, so the answer is 24. So in binary, how we can write? So we know, so the header length is 24, so that value will be divided by 4. So to get the header length field value, because to get the header length, we have to multiply by 4. So similarly, we have to divide by the 4 to get the value that will be added in header length field in 4-bit. So 6. So when you convert into the 60110, this binary value will be added in header length field. Next problem. An IPv4 datagram is carrying 1024 bytes of data. If there is no option information, what is the value of header length field? So IPv4 data is carrying 1024 bytes of data, and if there is no option information, what is the value of header length field? What is the value of total length field? So the option information is not available. So definitely the IPv4 size, header size is 20. So 1024 minus 20. 1024 plus 20, you will get the total length. So 1024 plus 20, that is 1044. This is the total length. So all the problems, just you have to remember the concept. If you see the next problem, an IPv4 arrived with an offset value of 100. So offset value is given. How many bytes were originally sent source before the data in this fragment? So offset value is given, and before this datagram, how many bytes of data transmitted? It is very easy to calculate. How the fragmentation of value we can calculate? By dividing 8. So this 100, we have to multiply by 8 to get the first byte value. 100 into 8, that is 800. So before 800, how many bytes of transmitted? 0 to 799. So we can easily calculate this. Had 800 bytes of data sent before the data in this fragment. Because 100 multiplied by 8, that is the first byte number of the datagram. And before that, 0 to 799 bytes of data transmitted. So 0 to 799 means 800 bytes of data. Datagram. The M bit is 0. So more to fragment, bit is 0. So the value of is 5. And header length is 20. 5 into 4, that is 20. And the value of total length is 200. So data length is 180. 200 minus 20. Value is 200. So offset value is 200 given. So 200 into 8. That is 1600. So what is the number of first byte? So what is the number of first byte? 1600. 200 into 8. And number of last byte. So the number of last byte, how you can calculate? The total then. So 1600 plus 200 minus 1. So 1600 plus 199. This is the last fragment. Sorry. Last byte in this datagram. Is this the last fragment, the first fragment, or middle fragment? Here m equal to 0 means more fragment is 0. So, and offset value is not 0. Offset value is 200. So therefore, this fragment is the last fragment. So we can easily calculate. See. So data size 200. minus header length 5 into 4, that is 20. So 180 bytes of data. Offset value 200 into 8, that is 1600. So the number of first byte offset value is 1600. The number of last byte. So 1600 plus offset value, 1600 offset value plus data size minus 1. What is the data size? 180. So 179 plus 179, that is 1779. Equal to 0, offset is not 0. Therefore, the fragment is last fragment. So even orally you can calculate these problem, which is very simple. Next, the size of the option field of an IPv4 data is 20 bytes. What is the value of header length in the binary? So size of option field of an IPv4 datagram is 20 bytes. So option field value is given, that is 20 byte. And what is the value of header length? So 20 byte size of option and 20 bytes the size of header. So 20 plus 20, that is a 40. So you get that header size is a 40. So 40 you have to divide by 4, because to get the actual header length we have to multiply by 4. And if you want to calculate the header value, you have to divide by 4. So 40 divided by 4, that is a 10. So 10 you have to write in a binary. So 1010 binary. So this is the value of header. Next, the value of header length in an IPv4 datagram is 7. So header length value is given, that is 7. How many option bytes are present? So 7. So header length is 28. So how many option bytes are present? So header length is 28. So 20 is actual header length if no option is there. So 28 minus 20 is equal to 8. So what is the size of option field? That is a 8, because actual header length is 20. Na? So 28 minus 20 is equal to 8. So all the problems are very easy in unit. The problem I have uploaded on Moodle yesterday only. You can download and read this problem. If you have any doubt, you can ask me through WhatsApp personal chat. I can explain the problem in detail. So in the next week, again I have scheduled 3 lectures. In these lectures, I am going to cover the different protocols like distance vector routing protocol, link state routing protocol, and RIP protocol and OSPF protocol. Vector and BGP protocol is not in your syllabus. So I will cover intra-domain routing protocol, distance vector, and link state, as well as TCP and UDP. So next coming 3 lectures, I will cover this part: IP, link state, OSPF, TCP, UDP. So all you should attend these lectures, though these lectures are online, but patient should listen these lectures, because in interview, the interviewer may ask you these questions. The CN is an important subject, and everyone knows, those who are computer engineers, what is TCP, what is UDP, what is IPv4, what is IPv6. And if you are attending lecture, you can easily remember this concept for the long time, and it will help you at the time of interview. Again, this time is very difficult. Dear students, apart from this lecture, I want to talk with you for 2-3 minutes. Then I will end this session. This year, the time is very for even the IT companies. You are looking the situation, the scenario, what is going on all the world. What are the financial, share market, how going to down day by day. So even the news are coming. I am not posting this news on your group. How the IT companies are reducing their employees. So again, the next year will be very challenging for the placement. We don't know actually up to the when this corona, how much this corona will affect the all over the world, and when the market will be recovered. But you should try. It is not the case the placement will become zero. The company will come, but you compete with your classmate only. To our college, or if you are going to the another college, you are competing with very few students. So you should compete with your classmate only. So this is the right time you are getting those who will utilize this time for the aptitude preparation to learn the basic programming concept, the OOP concept, the value-added skill. You do the courses, webinar, the different books courses, and learn the object-oriented concept. Because mainly all the IT are focusing how much you are very good in object-oriented programming concept. Even I am doing a different course, a Moodle course. Uh, uh, So actually, this is a very right time. You should utilize this time to develop your skill, because after 4 or 5 months, you will be appearing for the different companies. Okay, you should utilize this time, a very good time, but you improve your aptitude skill as well, the programming skill, the basic concept. You should not learn, but you should very clear your object-oriented concept. You should know all the concept: inheritance, polymorphism, encapsulation, data typing, parameter passing. You should able to explain this concept with the example. You should able to write a small program for this concept. You ask your seniors what type of question company mainly ask for the programming. So you will prepare this concept, and even though situation is not good, but still you will be placed if you will prepare. If you will prepare for the interview. Okay, thank you. So today we'll stop this session. I will mark your attendance and then you can leave the session. Okay. Thank you, dear participants. You can leave the session. I have marked your attendance. Hello?